Hi, my name is Ravi. Welcome to my channel, Payment Talks. Welcome back. If you learned payments in the empty world, you know the F21. You may not be able to code the specification, but you know what it does. You send an empty 103 to Swift, and Swift sends back a header that starts F21. Field 451 contains a 0. Custody confirmed. The debit can be booked. Simple, clean. Every back office on the FIN network was built around it. In the ISO 20022 world, that signal does not exist as a named message. And for a long time, nobody in the industry could give you a complete answer about what replaced it. This video closes that gap. When I moved from implementing MT based payment systems to building CPP plus Rails, the F21 was one of the first things I went looking for. I read Swift rulebooks, I read the CBPR Plus usage guidelines, I found references to access messages, to something called the data PDU, and to transaction manager. But nothing pointed to a single named ISO 20022 message that said, "This is the network level acknowledgement for a PAX 8." I asked practitioners at banks, fintechs, and consultancies across the industry. Most did not know. Some pointed at PAX 2. Other pointed at the data PDU with a sudo ACK embedded inside it. Neither answer was complete. The answer, it turns out, is that you are looking for the wrong thing. The architecture itself changed. What was a named message in FIN became a transport layer event in the MX world. Once you understand why, the whole acknowledgement model becomes clear. That is what this video explains. Before we get into the mechanics, we need to establish something that payment operations teams consistently get wrong. An acknowledgement is not one event, it is three separate events happening at different points in time with different operational consequences. The first is custody. Custody means the network has received your message and accepted responsibility for it. Nothing more than that. The second is delivery. Delivery means the network has successfully placed the message in the receiving bank's queue. The third is settlement status. Settlement status means the receiving bank has actually processed the payment and confirmed the outcome. Treating a custody signal as proof of delivery or treating a delivery notification as settlement confirmation is one of the most common structural errors in payment back office design. Keep these three events distinct in your mind throughout this entire video. Every signal we discuss belongs to one of these three categories and only one of them. Let us start with the empty baseline. First, let us be precise about what the F21 actually is, because most people describe it incorrectly. The F21 is not a field number. It is not a message number in the way MT103 or MT202 are. It is a combination of two identifiers in the FIN basic header block. That header is the first block of every FIN message. The F is the application identifier. It identifies the FIN application. F means FIN. The 21 is the service identifier. Service 21 is the ACK and NAC service. When Swift sends back a header beginning F21, it is telling you this is a service message from the FIN ACK NAC service. The BIC and session and sequence numbers in the rest of the header identify which message this acknowledgement is responding to. The full response is called the TRAC, Transmission Input Received Acknowledgement. It fires within milliseconds of Swift receiving your message before any business processing has occurred. It is a pure custody signal at the transport layer. Here are real format examples of the F21 in both its forms. On the left, the ACK. Field 177 contains the slice processor's timestamp, the exact moment Swift safe stored your message. That is the custody timestamp. Field 451 contains 0. 0 means Swift has accepted the message. Custody is confirmed. The debit can be booked. Job done. On the right, the NAC. Field 451 contains 1. 1 means the message was rejected. It never entered the Swift network. Field 405 carries the rejection reason code. In this example, Y01. The fix and resend cycle starts here. The entire back office model for MT was built on these two outcomes. You parsed field 451. If it was 0, you moved forward. If it was 1, you routed to an exception queue. Clean, binary, single signal. The F21 ACK and NAC were just the first two signals in the MT model. There were four more. Let me walk through the full stack. F21 ACK, custody confirmed. F21 NAC, rejected before entering the network. MT010, non-delivery warning. Swift has the message in custody but cannot reach the receiving bank within the configured time frame. The payment is in flight but stalled. MT011, delivery notification. Swift has delivered the message to the receiver's queue. The sending bank's obligation is met at this point. MT012, used in FIN copy flows. The copy destination has received and authorized the transaction. MT019, abort notification. Swift cannot deliver. The message is permanently cancelled. Rebooking is required. Notice what is around the entire stack. One system. In FIN, Swift owned both the transport layer and the message format. Everything was a named message type. Every signal came from one source. Banks built their back offices around this single source model for decades. That is why the transition to MX is not just a format change, it is an architectural change. The architecture changed. That is the answer. Let us understand exactly how. In FIN, the network and the message format were one proprietary system. Swift owned both. That is why every signal could be expressed as a named message type. The F21 was a service message within that unified system. In the MX world, the architecture separated. SwiftNet is the transport layer. ISO 20022 is the international open message standard. They are two separate things governed by different bodies within different namespaces and different versioning cycles. When transport and message standard are one system, custody can be expressed as a named message. When they separate, custody becomes a transport layer event. It is no longer a message in the ISO 20022 sense. It is a signal from the transport layer surfaced through the middleware that connects SwiftNet to the bank application. That is why there is no ISO 20022 equivalent to the F21. It is not an omission. It is a structural consequence of the architectural change. So, what does the bank actually receive? The data PDU. Before we read the data PDU, we need to understand where it comes from because getting this wrong leads to integration errors. The bank sends a PAX 8 on FinPlus. SwiftNet's store and forward platform SNF receives the message and stores it. SwiftNet then generates an SNF acknowledgement at the transport layer. Now, here is the key point. The data PDU is not generated by SwiftNet. It is generated by SAA Alliance Access, the Swift messaging middleware. SAA receives the SwiftNet SNF acknowledgement and wraps it into its own data PDU format. The namespace is this. This is an SAA namespace, not a SwiftNet namespace. SAA then delivers the data PDU to the bank back-office application. Why does this distinction matter? Because banks using custom SNL integrations or third-party interfaces that connect directly to SwiftNet without using SAA do not receive a data PDU. They receive the raw SwiftNet SNF response in Swift XML format. If your integration team does not know which layer they are integrating at, they will parse the wrong document. Let us look at the actual data PDU. These five elements are what a bank received as the acknowledgement for a pack site sent on FinPlus. Network delivery status equal to network act. This is the custody confirmation. This is a functional equivalent of field 451 equal to 0 in the old F21. Swift has accepted the pack site into the SNF queue. Custody is established. Service equal to Swift FinPlus. This confirms the acknowledgement is for a FinPlus message, not a legacy Fin message. The service name in the data PDU is the mechanism that tells you which rail the payment traveled on. SNF input time. This is the custody timestamp. It is the functional equivalent of field 177 in the F21. This is the exact moment Swift stored the message. When you book the debit, this is the timestamp you anchor to. Reference. The UETR of the original PAX 8. The unique end-to-end transaction reference flows through from the original payment instruction into the custody acknowledgement. This is what makes end-to-end correlation possible. Swift empty response in the response payload attributes confirm there is no business content in this signal. It is a pure protocol signal. No payment status, no business response, just custody confirmation. Now look at this element inside the data PDU, the sudo ACNAC. This is where a lot of MX implementations go wrong. Inside the sudo ACNAC, SAA has embedded the old F21 format, the complete fin header block, field 177, field 451 equal to 0, field 311 equal to ACK, field 108. Why? Because banks built their back office systems to parse the F21 over decades. SAA generates this backward compatible content so that legacy systems expecting an F21 can continue to process acknowledgements without modification. It is a transitional arrangement. This is the wrong signal to parse. The pseudo ACNAC is generated by SAA middleware, not by SwiftNet. It does not carry native FinPlus error codes. It does not surface the UETR in the correct MX correlation structure. Back office systems that parse field 451 inside the pseudo ACNAC are functional, but they are running on backward compatibility content. They are not natively MX systems. The correct design is to parse network delivery status and SNF input time. Those are the native MX signals. That is the intended architecture. The data PDU covers the custody signal. The delivery lifecycle, which in MT was covered by MT010, MT011, and MT019, became a set of proper ISO 20022 messages. These are the XSYS messages. The XSYS messages are real ISO 20022 messages. They have a business application header, a document element, an ISO 20022 namespace, and a published XSD. But they are generated by Swift's own infrastructure, not by the sending or receiving bank. They are system to participant signals. XS010 maps to M2 MT010, the non-delivery warning. XS011 maps to MT011, the delivery notification. I will come back to this one specifically in a moment. XS012 maps to MT019, the abort notification. XS011 through XS03003 handle Y copy authorization and refusal flows, which map to MT096 and MT097. XS008 and XS009 cover queue status. XS015 and XS016 cover retrieval requests and reports. The MT to MX mapping is clean here, one to one across the delivery lifecycle. Let me come back to XS011 because this is the most common operational gap I see in teams migrating from Fin. In Fin, MT011 delivery notification behavior was configured at service level. If your service was configured to receive it, you received it. Banks expected it as a normal part of the payment confirmation flow. In FinPlus, XS011 must be explicitly requested. You must configure it per flow or per message depending on your implementation. Without that configuration, no XS011 is generated, even when delivery succeeds. Think about what that means operationally. Your pack set was sent, the data PDU confirmed custody, the payment was delivered to the receiver's queue. But if delivery notification was not configured, your back office receives no signal confirming delivery. The operations teams sees silence. They have no way to distinguish between successful delivery and a delivery problem unless they are actively tracking the UETR through other channels. This is a functional requirement that must be designed into every MX payment flow from day one. It is not a default. Now we need to talk about transaction manager because TM fundamentally changed the acknowledgement model in ways that the access messages alone do not reveal. In the empty world, Swift's role was to deliver messages. The network validated format ensured security and routed to the correct destination. It did not apply business rules to payment content. In the MX world, for CBPR plus cross border traffic, that changed. Transaction Manager is Swift's business processing engine. It sits between sender and receiver and it applies business level validation after the network custody ACK has already been sent. This is a fundamentally new concept. In the empty world, if you received the F21 ACK, you knew the network had done its job. There was no second validation layer between the ACK and the receiver. In the MX world, you can receive a data PDU network ACKed confirmation and then have transaction manager apply its own business rules to that same payment afterwards. Those are two separate events in time with two separate possible outcomes. Understanding that is essential to designing correct back office exception logic. Let me show you the full two-stage model. Stage 1 is network validation. When the pack site enters FinPlus, the network validates format, schema compliance against CBPR plus usage guidelines, UTR uniqueness, and the RMA relationship. If stage 1 passes, the bank receives the data PDU with network delivery status equal to network ACKed. Custody is confirmed. The SNF input time is the custody timestamp. If stage 1 fails, the bank receives network nagged, no custody, fix and resend. The custody boundary, this is the line between stage 1 and stage 2. Custody transferred at stage 1, stage 2 has not begun yet. Stage 2 is transaction manager. After the network act, transaction manager applies business rules. TM can reach three outcomes: processed, bypassed, or aborted. Each outcome has its own signal and its own operational consequence. The critical insight here is that stage 1 and 2 are independent events. Receiving a network agged data PDU does not guarantee that stage 2 will succeed. You must track both stages independently in your transaction management system. The three TM outcomes each have different operational consequences. Let me walk through them. Processed. TM validates the message, applies data integrity rules, and routes it to the receiver. This is the normal expected outcome. If delivery notification is configured, the bank receives XS011 confirming delivery. Bypassed. TM cannot apply its rules to this message. It delivers the message via the sender's original channel without TM enrichment. Bypassed is not an abort. The receiver still gets the message. There is no failure signal. The payment completes. TM simply did not apply its processing layer. Aborted. TM has found a business inconsistency it cannot reconcile. The message is not delivered to the receiver. XS012 is generated with TM specific error codes beginning SW.TM. The reason I want to be precise about bypassed is that operations team sometimes see the absence of TM processing indicator on a payment and treat it as an anomaly. It is not necessarily an error. It may simply mean TM bypassed that specific message for a defined reason. This is the scenario I want you to be able to handle correctly because it catches teams off guard. At T1, you send the packset. At T2, you receive the data PDU. Network delivery status is equal to network agged. Custody is confirmed. Your system books the debit. This is correct behavior. Then at T3, you receive XS012. Transaction manager has aborted the payment after accepting the custody. The message was never delivered to the receiver. You now have a situation where the debit is booked, custody was confirmed, but the payment did not complete. These are two separate events requiring two separate exception paths in your back office. The debit booking at T2 was correct based on the information available at that time. The exception handling at T3 must unwind that debit and route the transaction to an investigation queue. Back office systems that treat network act as a final success signal are wrong by design. The network act confirms stage 1. It says nothing about stage 2. Given what I just described, you might be concerned that TM aborts are a common occurrence. Let me be precise about when they actually happen. TM aborts occur almost exclusively in cover payment scenarios. A cover payment involves a Pax8 customer credit transfer and a Pax9 COW financial institution credit transfer moving together. TM validates that the data elements across both messages are consistent. If they are not, if the amount does not match or the beneficiary details do not align, TM aborts. For straightforward single leg Pax8 customer credit transfers, TM aborts are rare. Most TM issues on single leg flows result in bypass, not abort. A note for teams still running some message types on FIN. When TM aborts a payment that originated from a FIN sender, the MT019 abort notification carries service code 619 TMR. This code identifies transaction manager as the source of the abort. Most legacy back office systems do not parse that code. The result is that TM aborts arrive as MT019 messages, but the operation teams has no way to distinguish them from normal network delivery failures. They are operationally invisible. That is a high risk state. Let me now address the question that comes up every time acknowledgements are discussed in the MX context. What about PAX 2? PAX 2 is not the F21 equivalent. Let me explain what it actually is in each context where you will encounter it. In CBPR plus correspondent banking, PAX 2 is a business level payment status message. It is sent by the receiving bank, not by SWIFT. It is bilateral in nature and not processed by transaction manager. The most consistent use case in practice is the negative RJCT, meaning the receiving bank is rejecting the payment. For positive status reporting, the Universal Confirmations Framework, which became active with standards release 2022, is driving adoption by requiring SUPE and PSPA institutions to confirm the outcome for PAX 8 payments received on FinPlus. In domestic RTGS settlement, PAX 2 plays a different role. Here, it is generated by the RTGS infrastructure, not by the receiving bank. The RTGS acts as the system operator. It intercepts payment instructions through the Y copy mechanism, applies settlement logic, and when settlement occurs, generates a PAX2 as the settlement finality confirmation. This PAX2 carries legal weight in the domestic context. It is the settlement event. These are not the same message with two different contents. They carry different operational weight and must be handled with different booking logic. A PAX2 from a CBPR plus correspondent triggers a status update. A PAX2 from an RTGS triggers settlement finality. Your back office must know which context it is operating in. And in neither context is PAX2 the network level custody signal. It is not sent by SWIFT. It is not the F21 equivalent. Now, let me make this concrete for back office and integration teams. 5 things changed in system design. Each one requires a deliberate response. Change 1. The custody signal is no longer a named message type. In MT, you received an F21 message and you parsed field 451. The logic was trivial with two outcomes. In MX, you receive a data PDU and you must parse SAA network delivery status and SAA SNF input time. The semantic is identical, custody confirmed or rejected, but the structure is different, the namespace is different, and the parsing logic must be rebuilt from scratch. The pseudo ACNAC inside the data PDU lets you continue parsing field 451 as a backward compatible shortcut. That is functional, but it means you are processing SAA generated backward compatibility content, not the native MX signal. You miss the native FinPlus error codes and the UETR correlation structure that comes from processing the data PDU natively. Change 2. The NAC error codes changed and they changed significantly. In MT, NAC codes were H codes and Y codes. Y01 for a specific format failure, for example. One family of codes, one exception queue in most back offices. In FinPlus, NAC codes are SW codes and they fall into distinct categories: format errors, UTR uniqueness errors, RMA relationship errors, CBPR plus usage guideline violations. Each of these categories requires a different remediation path. A UETR error means you need to regenerate a new end-to-end reference. An RMA error means you need to verify your bilateral relationship configuration. A CBPRS plus usage guideline violation means a content compliance issue in the packset itself. If your back office routes all NAC conditions to the same exception queue, you are losing the routing intelligence that the native FinPlus error codes provide. Processing the data PDU natively restores that intelligence. Processing only the pseudo ACNAC collapses all of these into a single field 405 code. Change 3. Delivery notification is now opt-in. In Fin, MT011 behavior was configured at service level. If your Fin service was set up to receive delivery notifications, they arrived automatically when Swift delivered your message to the receiver's queue. Many banks relied on MT011 as a checkpoint in their payment configuration workflow. In FinPlus, Access 011 must be explicitly requested. You must specify delivery notification as a requirement for your FinPlus flow configuration or per message, depending on your implementation design. Without that configuration, no Access 011 is generated for any message, regardless of whether delivery succeeds or fails. Your back office simply never receives the delivery confirmation signal. Operations team that were relying on the MT011 equivalent in their confirmation logic will find a gap in their process when they go live on FinPlus, unless this was explicitly designed in. If your payment flows require confirmation delivery to the receiver's queue as a process checkpoint, this is a functional requirement. It must be specified. Change 4. Abort handling now requires 3 paths, not 1. In the empty world, MT019 meant one thing: rebook. Swift could not deliver, cancel the instruction, rebook the new change. In MX, Access 012 can mean three very different things, and the correct remediation action depends entirely on which category of abort you have received. An Access 012 with SWSNF codes is a network delivery failure. The message expired or hit the maximum retry count. The correction action is rebook. An Access 012 with SWTM codes in a cover payment scenario is a TM abort. The correct action is to investigate data consistency first. Do not rebook until you understand why TM rejected the message. If you rebook without investigating, TM will abort the replacement message for the same reason. An additional consequence: all subsequent legs for the same UETR will bypass TM after a TM abort. A TM delivery failure after processing requires you to check the transaction copy state before any action. Do not rebook blindly. The payment may have been partially processed. A single abort equals rebook rule is incorrect. In the MX world, error code categorization is the new operational discipline. Your exception routing logic must read the error code, determine the abort category, and route to the appropriate remediation path. Change 5. The UETR is now the primary correlation reference, replacing MIR and MUR. In the empty world, payment systems correlated acknowledgements and notifications using the MIR, the message input reference, and the MUR, the message user reference. Both were Swift specific constructs. In the MX world, the UETR, the unique end-to-end transaction reference, is the primary reference. As we saw in the real data PDU example, the UETR appears as SAA reference in the custody acknowledgement. It flows from the original pack site through the data PDU, through Access 012 abort notifications, and should flow through all internal systems for the full lifecycle of the transaction. This means every internal system that touches a payment, the core banking system, the payments engine, the reconciliation platform, the operations dashboard, must carry the UTR as the first class reference from the moment the backside is generated. If the UTR is stored only in the payments hub and not propagated through, you lose the ability to correlate the custody acknowledgement back to the original instruction automatically. MIR and MUR correlation logic must be replaced. UETR correlation logic must be built in from the start. November 2025 marked the end of the empty coexistence period for interbank payment messages. The network level migration to ISO 20022 is complete. Back office migration is not. Banks sit in one of the three states today. State 3 first, the highest risk. Some message types remain on FIN. Transaction Manager interoperability means FIN senders can trigger TM processing. MT01 aborts from TM carry 619 TMR as the service code, identifying TM as the source. Most legacy systems do not parse that code. TM aborts arrive as standard MT019 messages. Operations team have no way to distinguish them from network delivery failures. TM aborts are operationally invisible. That is a high risk state. State 2, medium risk. The back office has moved to FinPlus but still parses field 451 inside the sudo ACNAC. Functional. But reconciliation gaps exist because native FinPlus error codes are not processed and UTR correlation is not done natively. Exception routing is imprecise. State 1, correct design. The back office parses data PDU network delivery status and SNF input time natively. UTR is the primary correlation reference. XS012 aborts are categorized by error code. Delivery notification is configured per flow. This is the intended architecture. Let me now give you the complete picture. Every empty signal mapped to its MX equivalent. F21 ACK maps to the data PDU with network delivery status is equal to network ACKed and SNF input time as the custody timestamp. F21 NAC maps to the data PDU with network NACKed and native SW error codes. MT010 maps to XS010. MT011 maps to XS011 with the critical note opt-in only. MT012 in FinCopy maps to XS001 through XS003 in YCopy flows. MT019 maps to XS012. Now look at the annotation on the F21 row. No named ISO 20022 equivalent. Transport layer event. That is the answer to the question that opened this video. The F21 has no successor message in the ISO 20022 catalog because what it did, confirming custody at the transport layer, is no longer expressed as a message. It is expressed as a field in a middleware document. The architecture changed and the acknowledgement model changed with it. If this video answered a question you have been carrying for a while, there is more depth available on the related topics at Payment Talks. Subscribe to the channel and you will not miss the next one. Until next time, keep smiling and keep learning. Thanks for watching this video. If you like this video, please like, subscribe and share for more such interesting topics on payments.